Good morning, dear student. In today's lecture, we will discuss the important topic of our syllabus, of our chapter, that is the type of magnetic materials. So, in previous lecture, we already discussed that the orbital and the spin motion of electrons and the interaction between these electrons is the origin of magnetism. So, whatever the and spin motion orbital and spin motion and the interaction between these electrons, orbital and spin motion of electron and interaction between these electrons results or forms the origin of magnetization. So orbital and spin motion and the interaction between these electrons forms the origin of magnetization. Different types of magnetic materials are due to differences in their response to external magnetic field. Second important point is that different types of different types of magnetic material different types of magnetic material are due to different types of magnetic materials are due to the response are due to the difference in their response. Different types of magnetic materials are due to difference difference in their response to external magnetic field external magnetic field. So this is also the important point. The first one, sorry, we are very much familiar. Whatever the orbital and spin motion of electrons and the interaction between these electrons forms the basis of magnetization. Different types of magnetic materials are observed, and they are due to the differences in their response to external magnetic field. Some materials are much more magnetic than others. The reason is some materials there is a strong interaction between atomic magnets, whereas in another material there is a no interaction between the atomic magnets. So depending on the magnetic behavior of materials, next important point is also important, that is depending on the behavior depending on the magnetic behavior of magnetic behavior material depending on the magnetic behavior of a material, they are they are classified into into five major group five major group five major groups. That is, first one, that is diamagnetic material. Second, paramagnetic material. Third, ferromagnetic. Fourth, ferrimagnetic. And the last one is antiferromagnetic material. So they are classified into diamagnetic. Second, that is paramagnetic, then ferro, then ferry, and the last one is antiferro. antiferromagnetic material. Antiferromagnetic material. So depending on the behavior in external magnetic field, the magnetic material are classified into five major groups. Sorry, that is diamagnetic, paramagnetic, ferromagnetic, ferrimagnetic, and antiferromagnetic. So let's discuss the first one, that is diamagnetic. So in this lecture we are very much interested in only diamagnetic material. So diamagnetism is a weak magnetism and is the fundamental property of all matter. Diamagnetism is mainly due to non-cooperative behavior of the orbital electrons under application of external magnetic field. So if you consider this diamagnetism or diamagnetic material, diamagnetism is a weak magnetism. Diamagnetism is a weak magnetism and it is the fundamental property of matter. It is the fundamental property of all matter. This is the important part. So this diamagnetic, it is a weak magnetism. Diamagnetism is a weak magnetism and it is the fundamental property of all matter. This diamagnetism is mainly due to this diamagnetism. So if you consider, this is first, this is second. Diamagnetism is due to non-cooperative behavior. Is due to non-cooperative behavior of the of the orbital electron under application of external magnetic field. So why the material is diamagnetic, or why this diamagnetism is occur in the material? The diamagnetism is due to the non-cooperative behavior of the orbital electrons under the application of external magnetic field. In diamagnetic substances, all the atoms have a pair electrons and there is no unpair electrons. So the main reason is important, that why this some material they are act as a diamagnetic. Because if you consider what is the reason for this diamagnetism or weak magnetism, that in diamagnetic substances in diamagnetic substances all electrons or all the atoms, we can consider all the atoms have a pair electrons and there is no unpair electron, and there is no unpair electron in the shells. In diamagnetic substances, all the atoms have pair electrons and there is no unpair electron in the shells, and thus the net magnetic moment of the atom of diamagnetic substances is zero. The net magnetic moment, that is a magnetic moment of plus half electron, is cancelled by the magnetic moment of minus half spin of electrons. So we know that the electron having plus half spin and minus half spin, so the magnetic moment due to the electron having plus half spin is cancelled by the electrons having spin minus one half, and therefore the net magnetic moment of the atoms of a diamagnetic substance is zero, and there is a non-cooperative behavior of the orbital electrons because there is a no unpaired electrons, so there is a no effect of external magnetic field on this diamagnetic material, and therefore this diamagnetism is a weak magnetization because there is no effect of external magnetic field, that is the magnetic lines of force cannot passes from this material because all electrons are pair, and there is no effect of external magnetic field on this material because there is no unpaired electrons and all the electrons are pair. However, when external magnetic field is applied on these substances, these material are magnetized opposite to the field direction. Thus, they have negative magnetization. So, if you consider, they oppose the external magnetic field. They oppose the external magnetic field, and they are magnetized in opposite direction. That is, they are magnetized opposite to the applied magnetic field. So, whenever we apply external magnetic field, when external magnetic field is applied, the diamagnetic material, the diamagnetic the diamagnetic material magnetize in opposite to the field direction, in opposite to the field direction, in opposite to the field direction, and thus they have negative magnetization. Thus they have negative magnetization. Thus they have negative magnetization. So that means for diamagnetic substances, the susceptibility, that is magnetic susceptibility, is a negative. So if you plot a graph of magnetization versus applied magnetic field strength, if you plot a graph between the magnetization versus the applied field strength, applied external magnetic field strength, then we get such a kind of graph for this diamagnetic material. So this is the applied field strength, this is magnetization, and if you see this graph, this magnetization, okay, the magnetic susceptibility, in this case the magnetic susceptibility slope, which is equal to magnetic susceptibility, is denoted by symbol chir or x, we can consider. So what it graph indicates, that is the magnetization, the effect of external magnetic field, it is in opposite, the magnetization is opposite to the field of external magnetic field, to the field field direction of external magnetic field. That is, if you consider, the magnetization is not in the same direction of external magnetic field, it is opposite to that of external magnetic field. And if you consider, by applying the temperature, if you consider the second graph, that is if you consider the temperature and the magnetic susceptibility, then if you consider, for diamagnetic material the magnetic susceptibility is constant, the magnetic susceptibility for this diamagnetic material is constant. From the above plot, that is the two plot, it can be understand that the magnetization is zero with applied field is zero. So we know that the magnetization is zero. So if you consider the field strength is here, the magnetization is also zero. But as we increase the applied